Good morning, Year 9 class. So, the title of the topic that we will be discussing today is how solids, liquids, and gases are able to change state when they are exposed to either a heat increase or heat decrease. So, the learning objectives for today are that by the end of today's lesson, you should be able to understand that solids, liquids, and gases are able to change state when they are exposed to either an increase in heat energy or a decrease in heat energy. You should also be able to explain what will happen to the particles in a solid, liquid, or gas when they are exposed to a heat increase or a heat decrease and their state is changed. So I will start off by introducing today's topic. So solids, liquids, and gases are able to change state when they are exposed to a heat increase or a heat decrease. So for example, water is able to change into ice. So the water goes from a liquid to a solid in the ice when the water is exposed to a heat decrease. On the other hand, water, which is a liquid, can also turn into water vapor, which is a gas, when the water, which is a liquid, is exposed to a heat increase. So, this is a table outlining the movement and closeness and arrangement of the particles in a solid, liquid, and gas. You may remember these structures from last week's lesson of the solid particle of the particle theory that we learnt in the solid, liquid, and gases, and we learnt the arrangement of how these particles are arranged, as well as what properties they have. So firstly, we know that the movement of the particles in a solid vibrate about at a fixed position. The closeness of the particles in a solid, they're extremely close together. The particles are arranged in a very orderly, strict fashion in a solid. In a liquid, the movement is quite, they're able to move around one another. They're fairly close together in a liquid, but not as close as in a solid. And the particles are randomly arranged. The movement of the particles in a gas are able to move fast around everywhere. The particles are far apart in a gas, and the particles are randomly arranged in a gas. So today's lesson, we're going to learn what happens to the structures of a solid and the liquid using this particle model theory when the state is changed. So when a solid is turning into a liquid, so for example when ice is turning into water, we can see that the particles, compared to here and here, they are able to move around one another, whereas in the solid they don't move around one another, they just vibrate about in a permanent position. So in here, the closeness of the particles are very close together. They don't really have much space to move. Whereas in the liquid, they are still close together, but not as close together as in the solid. And they are arranged here in a very orderly fashion. And in here, they're slightly a bit more random. So now we will start off by doing some activities. So in activity 1, I would like you to watch a YouTube video, and then I would like you to complete this worksheet, and I would like you to we will go together and explain what is happening, is happening to the movement of particles, the particle closeness and the particle arrangement, and whether heat energy is being gained or lost. We will do that together for when a liquid is turning into a solid, and then I would like you to do the rest when you watch the second video. And the second video, I'd also like you to take notes, and I'll stop the video where it is important for you to take notes, and this will enhance your knowledge about the particle movement theory for when a change of state is occurring. Then we will do an experiment, and this is the equipment list and the instructions, and this should enhance your knowledge of what is happening when the particulates of matter change state. Then we will round up the lesson with a Q&A session, which will be a conclusion.